Hey guys, I hope you were able to watch that Khan Academy video about the introduction of polynomials, and Mr. Khan gave a very thorough and in-depth look at what polynomials are and how to identify them. I'm going to simplify that a little bit in this little slides presentation and also be specific exactly what my expectations are for you guys when you start working on your homework. So let's begin. First, let's start talking about what is a polynomial. Let's give a brief definition. So a polynomial is the sum or difference of terms that have only whole number exponents, meaning they do not have a negative exponent or a fraction exponent. Examples of this include many of the things that we've seen throughout this whole semester regarding math, regarding Algebra 1 concepts, is just basically a simple equation, 3x plus 5. We have that plus, which is the sum of two different terms, 3x and 5. And so that's why it's classified as a polynomial. Another example, it could be more than two terms, of course, and Mr. Khan told you it could be an infinite amount of terms, could be a polynomial. Of course, that's really complicated. Right now, we're just going to focus on more simple things and things in our wheelhouse. And then, of course, it could be a single term. That could be considered a polynomial as well. Examples that are non-examples, which are x to the 2/3 or 5x minus 2. These are a fraction exponent and a negative exponent, and those are not examples of polynomials. All right, so there's two ways that we classify polynomials. First, by terms, and second, by degrees. Let's start with terms. There are four main classifications of polynomials. The first one is called a monomial, and that is basically a single term. Examples of this include just whole numbers, 13, 3x, any whole number multiplied into a variable, and it could be just x squared, because we know that even though there's no coefficient in front of that x, we know that it is a given that's a 1, and so we know that it is a single term. Also a 4y squared. Even negative coefficients are considered polynomials. What aren't considered polynomials are negative exponents, not negative coefficients. So this -2 works for what we're trying to do. Basically, any term that isn't added or subtracted to another term is considered a monomial, a single term all by itself. The other kind is called a binomial. Binomials are a sum of two monomials, and they have to be unlike terms. So, for example, 2x minus 5, 3x plus 5, 4 minus 6x, all of these qualify as binomial because they are two terms combined with a negative or a plus sign. Trinomials is another classification, a sum of three monomials. So putting them all together, 2x squared plus 3x minus 5, and of course this complicated one. And the reason it's only a trinomial is because this term right here is one term. It's a monomial term, and we're adding it to other different terms. So that is why it's considered a trinomial. And then a polynomial can be essentially any of the other terms that we have already gone through. For example, it's just basically considered a sum of one or more. So it could be this, it could be a binomial, it could be a trinomial, and it could be way more complicated where it has almost 5 different terms or more. So a polynomial just classifies anything that just goes above what we consider a trinomial. All right. The other part of how we classify is through degrees. Degrees are simply the largest exponent in a polynomial. The highest degree, if the highest degree is 0, we classify that polynomial as a constant. For example, any whole number. If that highest degree is a 1, we classify it as a linear. We've seen this before. Y equals mx plus b is that linear equation. This part right here, that mx plus b, is the linear portion of it. It has a single variable right here, and the degree of that is a 1 because it doesn't have a number up here. So we assume, or we know that it is a 1. If the highest degree is a 2, the polynomial is called a quadratic. And we're going to be getting a little bit more into this as we go throughout this quarter. it is a more complicated equation and line that we'll be discovering a little bit more, but that's simply essentially why we call it a quadratic. And if, because of that 2 right there, and if the highest degree is 3, the polynomial is considered cubic. So for example, this, the highest degree is that little 3, and so we call it cubic. It's not in standard form, I'll note, which we'll be talking about shortly. So let's putting it all together. In order to classify polynomials correctly, we must first identify leading coefficients, and we have to write it in standard form. So real quickly, what is a leading coefficient? A leading coefficient is that whole number in front of the variable with the largest exponent. For example, if the biggest number in a polynomial is 5x to the third, the degree is the third, so we know that it's a cubic polynomial. And that 5 is the leading coefficient. It's the coefficient attached to the variable that has the highest exponent, which is the 3. So if that's not confusing, it'll get better. And then we also have to put them into standard form. So by combining all like terms and exponents in descending order based on their degree. So if we have an equation that looks like this, we need to rearrange it so that the x to the third, because that is the highest degree, is in front. The x to the second, or the square, is next, and then the x to the 1 is last. And it should look like that. That is what we call standard form. And it's all based on the highest number of degree, and then we order them in a way that is descending from that highest degree. All right, so let's take a look. Let's practice this. And so I'm going to switch the view slightly so you can kind of see what my expectations are. So if I'm given an expression, and this is going to be part of your homework, I'm going to make sure that it is in standard form. I'm going to identify the leading coefficient. I'm going to classify by degree, and then I'm going to classify it by number of terms. First, 3x minus 7. Well, I know that it is already in standard form. So I'm just going to enter that in, add that in here, and I'm going to make sure that it fits within my little square. So that, I'm just going to repeat that. That's okay. That's all good. Leading coefficient. I'm looking for the leading coefficient. The leading coefficient is the number that is attached to the variable with the highest degree. Well, that happens to be that 3x. So I'm going to enter 3. That's my leading coefficient. What degree is it? Well, if it's x to the 1, I know it is a linear degree. And then how many terms are combined by a negative or a positive? Well, 2, the 3x minus the 7, so then I know it is a binomial. So that can be classified as a linear binomial. All right, let's look at the next one. 2x to the third minus 5x squared plus 7x. Okay, it looks like it's already in standard form, so I'm just going to enter that in as it is. So 2x to the third minus 5x squared plus 7x. Add it in. I'm going to shrink it down so that it fits. All right, sort of. Get in there. All right, what is my leading coefficient? In this situation, the highest degree is that 2x to the third, so my coefficient is 2 in front of that x to the third. Classify by degrees. Well, if it's to the third, if the exponent is 3, then I know it is a cubic degree. And then how many terms are there? There's 3 terms, so then it is a trinomial. So it is a cubic trinomial. Next one. So I'm looking 2 plus 6x minus x squared. That is not in standard form, so I have to rearrange that. So let's do it. So first I need to make sure I'm including the sign in here. So I notice that the highest degree is that x squared. It is also negative x squared. So I need to put it in negative x squared. Next would be 6x, so I'm going to add 6x, and then the last would be a whole number 2. All right, that is standard form, starting with the highest degree and working my way down to the lowest. I'm going to bring that into my box. So I'm looking at the leading coefficient. It would be that x squared or that negative x squared. So my leading coefficient would be a negative 1. Because it's squared, I know that it is considered a quadratic degree. And how many terms? Looks like there's 3 terms, so it is a trinomial. So it is a quadratic trinomial. All right, and here it's probably the easiest, or should be the easiest, although sometimes when they're really easy, they're also kind of confusing. So 9 is a polynomial. It is still in standard form. It's just 9. For some reason this didn't format. That's okay. And then the leading coefficient. Well, like Khan said in his tutorial, it could be 9x to the 0 power, which is 1. So the leading coefficient is that. It's 9. It is a constant because it does not have an exponent, and it is a monomial because it only has one term. So I'm going to do this so that it's all kind of the same. Okay, so what I want you guys to do, take these notes. I want you to download this. This is something that you can fill in. And just so you know, you can insert formulas. If you're in Google Docs, you go in here, you insert, and there is an equation button that you can throw in an equation if you wanted to. Otherwise, or if you wanted to print this off and handwrite it, take a picture and turn it in that way, that's fine. I'm looking for you to fill this grid out. I'm looking for you to classify the degree and number of term. For example, what's the highest degree? Well, that's an h to the 1, so it's a linear binomial because there's 2 terms, and that's what I'm looking for. And then this last part, I'd like you to simplify these terms. I want to combine like terms. So we're looking at all the exponents go together. So these x, 3x2 plus 4x2, those are combined to a single number. It would be 7x2. This negative 4x plus 2x, those are all combined. It would be a negative 2x and then plus 6. I want you to simplify this by combining like terms, okay? So that's our goal. Bring your questions and concerns to me on Wednesday when we will meet as a class at 9:45. All right, guys. Remember, I'd like to see it all done and turned in by Friday. All right, get to it. Hope you enjoy.